right now you see everything that you need to know about the data, but it's not very satisfying because it's all disorganized. Descriptive statistics allow you to organize the data. So we're going to make a frequency distribution, a frequency histogram, and calculate some measures of central tendency and dispersion for this set of data. We begin by making a frequency distribution. For a frequency distribution, you make a table. The table lists every value of the data that you have. And it's easier if you put it in order. So if we look at this data, we see, oh, we've got a 1, and there's a 2, 3, 4, 5. So those are the possible values for each of these data points. Then we count the frequency of each. So there's 1, 1, and there's 2 2s, and there's 1, 2, 3, 4 3s. And if we look, we see 2 4s, and the final one is 1 5. This is the frequency distribution in a table form. We can make it into a graph by putting the x and y coordinates. The score is x, 1, 2, 3, 4, 5, and the y-axis is equal to the frequency over here. So we had 1, 2, 3, 4. Let's make 5 levels on our frequency. There was 1, 1. So we make a bar that's 1 unit high, 1 frequency. There were 2 2s. So we make a bar that goes up to 2. There were 4 3s, 2 4s, and 1 5. And this is a frequency histogram. That organizes the data and tells us much more about it. But we want to know more about it. What is the center of this distribution? And how dispersed is it? How spread out is it? The center of that distribution, we calculate measures of central tendency. There are 3 different ways that we can do this. The easiest is the mode. The mode is the most frequent. We can see from either the frequency table or from the frequency histogram that 3 is the most frequent score. That's the mode. The median is the middle score. And so we have to have the same number above and below. Well, how many scores are there? There are 10 scores. So the median is going to be between 5 and 6. Well, there's one that's 1 and less. 3 of them, if you look and say, okay, there were 2 2s and 1 1, 3 and 4. So we know the median is going to be between the second and the third 3, but what's the difference between 3 and 3? Oh, it's 3. The median is the middle score. There is an equal number above and below it, approximately. The mean is the average, and we calculate it by taking the sum of all the scores divided by the number of scores. So we have to add up each of the scores. We can add them here. We can add them in the frequency table if we remember that we have 1 1, that's 1, and 2 2. So 1 plus 2 is 3, plus 2 makes another 5. We add these all up, and we're going to find that we have a sum of 30. And there are 10 scores. So the mean is equal to 3. These are 3 measures of central tendency. In addition to knowing the central tendency of the data, what's the middle, we also like to know how spread out the data are. And you can look at the frequency histogram and get an idea, but we'd like a number for it. So we calculate what is called dispersion. In order to calculate the dispersion, we need to know how far each score is away from the mean. We call that the deviation score. And that's an italicized F. The deviation score is the raw score minus the mean. which we're calling x bar. If we calculate a deviation score for each score in the distribution, we could have a bunch of those deviation scores, but if we calculate their average to see how spread out it is on average, it will always equal 0, because if you look at this, 1 minus 3 is going to give us 2, but 5 minus 3 is also going to give us 2, and this is a minus 2 and a plus 2. So in order to solve that problem, statisticians said, let's just square it, because if you take a minus 2 times a minus 2, you get 4, a plus 4. So the deviation scores squared divided by not the entire number, but n minus 1, this is called a correction for sampling error, is what is equal to the variance. In order to calculate the variance, we have to add up each of these deviation scores squared and then divide by the number minus 1. This is a correction for sampling error. So if we look at our frequencies, we can see that we have 1, 1, so 1 minus 3 is equal to 2. 2 squared is equal to 4. So that's the deviation score squared for that. There are 2 2's. The deviation from 2 minus 1 is a minus 1. Minus 1 squared is 1. And there are 2 of them, so we put them in twice. Now we get to the most frequent score, which is also the mean, 3. 3 minus 3 is 0. 0 squared is 0, but there are 4 of them, so it's 0 plus 0 plus 0 plus 0. Now we're up to 4. 4 minus 3 is 1. 1 squared is 1. And there are 2 4's, so we put it in twice. And finally we get to the last score, 5. 5 minus 3 is 2. 2 squared is 4. And so we have 1 4. 1 squared is equal to 1 1. All of this is divided by n minus 1. There are 10 scores, that's the n minus 1. So the variance is equal to this sum. We add them up, 4 plus 1 is 6, plus these 4 zeros is 6, plus 1 plus 4. The total is equal to 12 divided by 10 minus 1, which is 9, which is equal to 1.33. Now, we are not happy with this number because this is in a squared units, and we don't think about things as squareds. So statisticians have come up with a way to get rid of that, and they call it the standard deviation. The standard deviation is equal to the square root of the variance. So in order to calculate the standard deviation for this particular set of data, we simply have to take 1.33 and calculate the square root. Now I can't do that in my head, so I used a calculator earlier and I got 1.15. So now we have taken some disorganized data, organized it into a frequency table, made a frequency histogram, calculated 3 measures of central tendency, and we have a measure of dispersion in terms of the same units that we started out with in the standard deviation.